Hello friends and my dear students, as in the last session we have discussed about types of crystal structure and majorly we have focused on FCC, BCC and HCP. These are the diagrams which I have told you to draw on the paper so that you can better understand the characteristics of these three crystal structure, which is BCC. Then we have discussed FCC in the last lecture. Then we have covered the HCP. Okay, hexagonal closed pack. Okay, now today we are going to discuss about average number of atoms. Okay, average number of atoms are these. Average number of atoms are defined as the number of atoms which particularly belongs to a particular unit cell only. This is a unit cell calculation only, means the number of atoms in a particular unit cell, either for your BCC, FCC or HCP. For cubic cells, which are body centered cubic cell or face centered cubic cell, means for BCC and FCC this formula will work, first one, and for HCP, which is hexagonal closed pack cell, this formula will work. Okay, now let's see what are the nomenclature in this formula. And AB is the average number of atoms which we have to calculate, where NC is number of atoms in corner, and I is number of atoms in body's interior, and F is number of atoms in face center. Let's see how we can calculate an average or average number of atoms in cubic cell and HCP cells. Now for BCC, first is our NC, which is number of atoms in the corner. As you know that in the corner there are total number of atoms are 8, while in the body interior there is no atom, so it is 0, while in the face centered you will find out 1. Okay, so as per the formula of this cubic cell, by NC by 8, NF by 2, NI by 1. So NC by 8, NF by 2 or NI by 1. So you will get it as 2, means for BCC average number of atoms are 2. What are for the FCC? You will find out 8 for your corner atoms, 6 for your body interior, and F face centered are 0. Okay, from here. Okay, so as you can see, this is means face centered 6 and body centered are 0. So you can say the total number of atoms or average number of atoms in face centered cubic cell are 4. For HCP it is 12 in the your corners, 2 on the body and 3 on the faces. So total is 6 as per the formula. So you can note it down. For BCC it is 2 number of atoms, average number of atoms. FCC it is 4, HCP it is 6. Now move towards the coordination number. So basically the definition of coordination number is defined as number of nearest and equidistant atoms surrounding an atom under consideration. And for BCC coordination number is 8, for FCC coordination number is 12, and for HCP coordination number is 12. Means for FCC and HCP coordination number is same, while for BCC the coordination number is 8, and it is defined as nearest and equidistant atom surrounding an atom under consideration. If you will select any atom, the nearest equidistance and nearest and equidistant atoms will give you the coordination number. Okay, and all material tend towards low energy level because the net potential energy between two atoms decreases. Okay, because net potential energy repulsion and potential energy attraction will be equal at the point where you will create some kind of equilibrium. Okay, and the coordination number is indicate the material resistance offered. If the coordination number is high, then resisting power of that material to deform that will be high. So this is coordination number indicate material resistance offered by material to deform. Okay, now the next third thing we are going to study is atomic packing factor, APF. It is defined as the ratio of volume occupied by average number of atoms to the volume of unit cell. Let's see what are the volume occupied by average number of atoms and volume of unit cell. As you can see, the formula of this is N average into 4 by 3 pi r cube divided by volume of unit cell. For BCC APF, if you will calculate, then atomic packing factor for BCC is 0.68, and for FCC atomic packing factor is 0.74, while HCP atomic packing factor is same 0.74. Means density is going to decrease. Okay, The highest APF possible is the pure metal is 0.74. Such structure are called as closed pack structure. Okay, means for example FCC and HCP are called as closed pack structure, means the density will be high. Packing factor means the amount of for the sake of convenience you can say that out of 1 point means 74% of this particular cells will be filled. Okay, while here in BCC only 68% of atoms will be filled in that unit cell. Okay, now next is allotropy. This definition you have heard in your chemistry as well, and this is quite important as per as your exam point of view. Allotropy denotes the tendency of an atom of an element to exist in different crystal structure at different temperature and pressure. Means at different temperature and pressure, some elements will give or exist in some different crystal structures. Okay, that is called as allotropy. And similarly, there is also one term which is called as isomerism, which is not we are going to discuss here. That you can recall it by your previous in your 12th science book. Now, iron changes from BCC to FCC on heating at 910 degrees centigrade. Then what is the percentage change in density that you are going to calculate? So, density at FCC minus density at BCC divided by density at BCC. Basically, density is nothing but your atomic packing factor. As you know that atomic packing factor of FCC is 0.74 that we have written here. For BCC it is 0.68 divided by 0.68 multiplied it by 100. Then you will get the percentage change in density if iron is changing from BCC to FCC. That will be equals to 8.83%. And this is very important question for your numerical point of view in your university exam. They may ask such questions in your university exam. So I'm stopping here my session. I'll come with another content of this material science and engineering, which is your 3rd semester B.Tech mechanical engineering curriculum in the RTU. Stay tuned with our Engineering College Banswara YouTube channel for more such updates about the same content and even in different branches of engineering like mechanical, civil, electrical and computer science. Thank you so much.